Hi everyone, hope you are all doing well and safe. Welcome to the practical course of circuit analysis. Here's your lab instructor Nishita Alwaz. Agenda of this experiment includes 7 different sections: lab objective, equipment needed for the experimentation, theoretical background, software implementation, results and discussion part, conclusion, and the task assigned. The objective of today's experiment is to determine the response of filter circuit using NI Multisim software.
The basic equipment needed for the experimentation is NI Multisim software installed on the personal computer.
Firstly, we have to look at the theoretical background of this experiment. Most of the electrical equipments in our house, such as radio, television and computer equipments, work on direct current. But our power supply is alternating supply, means the AC source. That's why we need such kind of equipment that convert AC into DC. So the rectifier is a device that converts a pulsating alternating current into direct current. Apart from the DC component, the pulsating DC voltage that will be provided by the rectifier have unwanted AC components like the components of its supply frequency along with its harmonics, which basically known as the ripples. So for most application, the supply for our rectifier, basically from our rectifier, will make the operation of the circuit poor. If the rectifier output is smooth and steady, then overall operation of the circuit becomes better. So for making the output of rectifier more smooth, we will need a filter. Filter is a device that allows passing the DC component of the load and blocks the AC component of the rectifier output. The output of a filter circuit will be a steady DC voltage. Why we need filter? Here we have our AC input which is continuously varying. So we need a circuit that converts this AC input into the rectifier DC output. So we will use a bridge rectifier for the conversion of this AC input into the rectifier DC output. Bridge rectifier output basically has varying type of current, like it will start from 0 and it will reach at the maximum point. After this it will again moving towards the 0 point and then again moving towards the peak point. Means it will continuously varying. As we can see in the second graph, the output will continuously varying. So we could not call this a steady current because it will continuously vary, and we will not use this output for our equipments because it will consider as a poor circuit performance. So this output is rectified, but it will not a DC output and it will also not a steady output. Steady means not a single variation in the output, means it will constant. So we have to make this output steady, means one direction, DC current, one direction output. For this we will need a filter. Filter basically converts this continuously varying output into the pure DC steady output, one direction output. That's why filter is important in any power supply based electrical equipment. Now if we talk about the construction of filter, then filter can be constructed by using two main components, inductor and a capacitor. So what is the feature of inductor and what is the feature of capacitor in the production of filter circuit? So an inductor allows DC and blocks AC, and a capacitor allows AC and blocks DC. There are four common types of filters: capacitor filter, inductor filter, LC filter and pi filter. Now we will learn about each filter step by step. So the DC voltage we will receive after rectification have some ripples and AC signal. For that we will need filter circuit. Here we will use capacitor filter for the process of filtration. This filter is the cheapest and the simplest filter. In this, we will choose a large value capacitor. So here I have the center tape four-way rectifier circuit. In this circuit, I will connect the capacitor filter and check the response of the circuit. We know that if we use resistor in any circuit, then it is the opposition to the flow of current. So it is known as the resistance. Same as if we will insert capacitor in any circuit and any opposition that will offered by this capacitor is known as capacitive reactance. As we will see the formula of capacitive reactance in this slide, which is Xc equals to 1 divided by 2 pi Fc. We know that capacitor blocks DC voltage and passes AC voltage. So now we will understand how this phenomena will work. For DC signal, F equals to 0 because in DC signal there is no frequency. So I will put F equals to 0 in this equation. So Xc equals to 1 divided by 0 means Xc equals to infinity. It means it will work as open circuit for DC. So according to this formula, we will see where we can place capacitor in our this circuit diagram, series or the parallel fashion. We have already seen at the output of rectifier, we have AC and DC voltages. So now if we connect capacitor right there in series with the load resistance right there, so we have at the output of our load no DC, because right there we have AC plus DC, and we will if we will connect capacitor right there, then capacitor we know that blocks DC signal, so it will block DC signal and no voltage of DC signal will pass through load resistance. If we connect capacitor right there, so all the AC passes through this and we do not need such kind of AC signal. So this is the drawback of capacitor. If we place capacitor right there in series of load resistors, it will block DC signal and we will not receive any DC signal at the output of load resistors. And we have all the AC voltage if we connect capacitor in series of the load resistors. So that's why we will connect the capacitor in parallel with the load resistance. And that's why it is known as the shunt capacitor filter. So now if we connect capacitor in parallel with the load resistance, the input we have at the capacitor input size is basically we will name this as Vm. So we will have to look at this input at the capacitor size, where input voltage of the capacitor, right there side voltages, basically greater than or more than the voltage across the capacitor, then the capacitor will charge itself. If the voltage of this side, means the input side of the capacitor, is less than the voltage across the capacitor, then capacitor will perform discharging. So now if we consider we have positive at the input of diode 1 T1 and negative input as the input of a diode D2. Then diode D1 will be in the conducting state and behave like a short circuit right there. And for diode 2, we have negative anode. We know that diode D2 will become reverse bias and behave like an open circuit. As the input voltage increases, capacitor will become charged. So if we look at the output, capacitor output will be start from right there. If we have basically input voltage of the capacitor is greater than the voltage across capacitor, then our capacitor will start charging. So we have an increment at the output. Output will be increased as it is reaches at Vm, means the capacitor input voltage equals to the voltage across the capacitor. Then we have positive at this plate of capacitor, and after this capacitor voltage will be greater than the input side of capacitor voltage. As Vm is less than the capacitor voltage, so capacitor will perform discharging. That's why we have decrement in our waveform like this. As again Vm greater than the voltage across the capacitor, so we have the capacitor that will perform charging and we have increment in our waveform. As Vm reaches the voltage across the capacitor, so capacitor will perform discharging and we have the decrement in our waveform. So this is how we can make the filter output. Another thing we have to consider in this filter is time constant. So time constant in this whole scenario equals to RC, T equals to R3. So we need a large value of RC. As higher this value is, we can make more steady output, more DC, more one direction output, more steady output. So we will need a basically higher value of RC. Another factor is XC less than R, because as XC has low value, low resistance value, so that our AC signal will pass through it, and AC signal will pass through the ground, and we have output DC at our load resistance. As we have XC less than R, then our AC signal passes through the ground and DC signal will pass through the load resistance, and we will get DC signal at our output. So this is how capacitor can be used as a filter in any rectification process. Here we have the advantages and disadvantages of shunt capacitor filter. Shunt capacitor filter is a low cost filter. It has small size and weight. It has very good characteristics and it can be connected for both half wave rectifiers and the full wave rectifiers. This filter basically improves DC output, and this filter has one advantage. Disadvantage basically, capacitor draws more current in the circuit. Another filter in this experiment we have is inductor filter. For the filtration of AC components, we know that the fundamental property of inductor is that it will oppose any change in current through it. When the current flows through the inductor and it will changes, then a back EMF will induce in it, and that back EMF prevents the current from changing its value. This is the property of inductor that we are going to use it in this conductor based filter. Now where we will connect the inductor in the rectifier circuit, in series fashion or in parallel connection. So one important thing right there is inductive reaction, which is basically the opposition offered by the inductor to the flow of current. We know that X of L, which is basically the opposition to the flow of current and inductive reactance, is equals to 2 pi Fl. So XL is the inductive reactance. If we will put DC for DC current F equals to 0, then XL is obviously equals to 0. Means for DC, inductor will offer 0 resistance. It will easily pass the DC signal. So at the output of rectifier, we have AC plus DC, and we need basically only DC at the output of load resistance. So we will connect inductor in series with the load resistance. That's why it is known as series inductor filter. One more thing we will consider right there, we will take very large value of WL that will block AC signals. So now if we look at the advantages and disadvantages of series inductor filter, then here we have two advantages. Series inductor filter basically smoothen out the sudden changes in the current. It will improve filtering action at high load current. Furthermore, here we have three disadvantages. Series inductor filter reduce output voltage due to the drop across inductor. This inductor is bulky and large in size, means the filter it will not suited for half-wave rectifier. Third number of filter is LC filter. At the output of rectifier, we have pulsating DC. Now this output will go to the input of inductor. So what is the property of inductor? Inductor allows DC and block AC. So the AC plus DC signal we will achieve at the input of inductor. Inductor will block that AC component and passes only DC. In this DC, we have also some portion of AC component. After that, if this input will reach at capacitor, then capacitor passes AC signal to the ground and we have only DC at the output of load resistance. So ripples will be decreased at the output and we will get pure DC nearly. Moving towards the advantages and disadvantages of LC filter. LC filter has reduced ripples at the output. Action of the LC filter is independent of load current. Now we have the disadvantages of LC filter. LC filter has less output voltage. These filters are bulky and large in size. They are not suited to connect with half-wave rectifier. So the fourth number of filter is pi filter. The output of the rectifier is the combination of AC plus DC components. So the pi filter is the sum up of two capacitors that are arranged in a parallel fashion with a load resistor, and here we have another inductor that will be connected in series in the center of these two capacitors. So if we get the AC plus DC components at the input of capacitor 1, then we know about the property of capacitor. Capacitor passes AC signal and block DC signal. So capacitor C1 passes AC signal through it and pass the AC signal through the ground and basically block DC signal. So this DC signal will be passed through the inductor. Inductor has a property of passing the DC signal and blocking of AC signal. So we will get the DC signal at the output of inductor. After getting the DC signal at the output of inductor, we have some little bit of AC components. So for the proper removing of these components, we will connect another capacitor C2 which passes the AC component to the ground through it, and the remaining DC part will be passes through the load resistor. So in the result we will get DC component at the output of load resistance. So now if we talk about the advantages and disadvantages of pi filter, then here we have three advantages of pi filter. Pi filter produce more output voltage. Output will be contain less ripples. This filter is suitable to be used with both half wave rectifier and the full wave rectifier. So next I have the disadvantages of pi filter. Pi filter is large in size and weight, and the cost of this filter is also very high. To simulate our circuit diagram, we have to move towards the NI Multisim software. So first thing, we have to place all the components that are helpful for the construction of our circuit diagram. I will move towards this block, then pick power source and then pick AC power source. After this I will pick ground block and place it, and then I will move towards basic block, and then I will pick transformer of this type. Then I will place this transformer on NI Multisim window. Then I will pick the resistor of 1K as a load resistor. Then I will pick the capacitor of 50 microfarad on and place it on the NI Multisim software. So there are basically two components. I will copy the stuff, so I will select and pick cut. So further I will need basically two diode. I will move towards the diodes block, then I will pick this diode model and place it. Pick another diode of the same model and place it. So these are the components that are basically necessary items for the implementation or the testing of our circuit diagram. Now arrange all these components. Firstly, I have to change the value of AC source as 12 volt and pick the frequency item as 50 Hertz. Then press OK. Now arrange all these components. Connect resistor diode basically with the terminal of transformer. Then connect this diode with the positive terminal of transformer. Then I will connect AC source with the transformer. Then select capacitor and press Ctrl R. Select resistor and press Ctrl R. And arrange them in a proper way. Then I will connect a capacitor with the diode block. Then I will connect resistor. Then I will provide ground to the circuit. So this is how we can implement our circuit diagram. Next thing is the measurement of voltage across the capacitor. So I will pick oscilloscope and connect it. Choose channel A. So our circuit is completed. Now I will move towards run block. Double click on oscilloscope. So here I have the proper result of capacitor based rectifier circuit. We can see that we have nearly DC output, steady state output. but there are some oscillation for the removing or removal of basically these oscillations. We will choose regulator. But this is the proper result of our capacitor-based rectifier circuit. So this is how we can perform the experiment of filter. In the second part of this experiment, I will use inductor as a filter in the circuit. So for the inductor, I will just replace the capacitor with the inductor, and I will connect the inductor in series with the load resistor. So I have to delete this block and the winding also. Then I will pick the inductor of 1 Henry from the basic block. Pick inductor of 1 place it on NI Multisim and connect this inductor in series with the diode and load resistor. Then connect the terminals of oscilloscope with the inductor block. Now circuit is completed of the inductor based rectifier circuit. Run block and double click on oscilloscope. So this is how we can implement our circuit diagram of inductor based rectifier circuit. We can see that here we have the results of inductor based rectifier circuit. We will achieve the steady state output, but there are some oscillations, more oscillations as compared to the capacitor based circuit. So we have to make modification in our circuit diagram by using capacitor and inductor simultaneously in the next experiment. But here we can see that we have a little bit oscillations in our output. So this is how we can implement the circuit of inductor based rectifier. So in the case number 3, we have the same circuit equipment, except we will add one inductor and one resistor in series and parallel fashion in the same circuit. We will insert inductor in the series fashion, and we will insert capacitor in the parallel connection. So now insert all these components, moving towards this block, then moving towards basics, then capacitor. Pick the value of capacitor as 10 microfarad. And place it on the window. After this, I will pick the inductor of 21 Henry and place it on the multisim window. Connect inductor in series and capacitor in parallel. Press Ctrl R and now make connections. Connect ground and also connect resistor R1. Then connect the terminals of oscilloscope across capacitor. After all this connection, I have to run my simulation diagram. Press run button. Then I can see that by double clicking on the oscilloscope, I have the waveform of rectifier with the with LC filter. We have very pure DC waveform, near about DC waveform, like more steady output as compared to the inductor and capacitor filter. So this is how LC filter work in the connection with the rectifier circuit. So for case 4 and pi filter, we have to connect capacitor in one more capacitor basically in the parallel of load resistor or the parallel of already present capacitor. So all components will remain same as we have already placed on NI Multisim software for the implementation of LC filter. Just we have to add one more capacitor of 10 microfarad for making the pi filter. Moving towards this block, then moving towards the basic block, then capacitor. Pick the capacitor of 10 microfarad and place it on NI Multisim software. Select this capacitor and press Ctrl R and connect it. So now my circuit is completed. I have to just run the circuit diagram, double click, and here we have the output of pi filter. We can see that we have more smooth steady output of DC at the basically output signal of the rectifier by the help of pi controller or the filter. Now moving towards the result and discussion section. If we will use capacitor at the output of a rectifier circuit, then we will achieve DC steady output. But there are some ripples of AC output at the output of load resistor. Now in the second section, if we will use inductor as a filter at the output of a rectifier, then we will achieve DC steady output. That there are some ripples also at the output of load resistor. For third case, if we will use LC filter at the output of a rectifier, then we will achieve more steady DC output, as we can see the result in the slide. Last filter is pi filter. Pi filter rectify the output and produce more steady DC output as compared to the other filters we have studied before. So we will achieve more DC steady output, but these filters are costly and bulky in size. Finally, the conclusion is here. Filter used to remove the AC components from the output of our rectifier circuits. LC filter and pi filters produce accurate DC output, but they are bulky in size and costly. Furthermore, we have also learned about the LC filter, pi filter, inductor filter and capacitor filter simulation in NI Multisim software. Tasks assigned for this experiment are listed in this slide. This is all from my side. You are welcome to ask any question related to this topic. Thank you very much for listening to me.